This will be a video for 7th grade. We're going to do page 94C and 94D. On this section, I've just got some problems for us to solve, and we're going to be recognizing some properties. Properties of math, properties of multiplication, addition, etc. So if we look at this one, number 1, notice that our first fraction here is 5 over 2, and our second one was 2 over 5. When we practiced multiplying fractions like this, we saw these two 5s, we can make them 1s, right? We saw these two 2s, we can make those 1s, because we're reducing using commutative property. So essentially what we're doing here is we're multiplying by its inverse. So 5 over 2, the inverse of that is its reciprocal. It's 2 over 5. Those are inverses. It's like they're opposites, but they're not technically. It's not the word opposites. Inverse. But if I have two negatives, so if I have negative 5 halves times negative 2 fifths, that's going to be a negative times a negative is a positive, and 1 over 1 is 1. So there's our answer. And let's talk about the name of this property. We used multiplication, and we used an inverse. Okay, we used the reciprocal. We used the same number as a fraction, but we took it and flipped it over. So this is the inverse property of multiplication. And this one states that if you multiply something by its reciprocal, it's going to equal 1. So there you have it. It's 1. Number 2, pretty nice problem. Negative 132 and 59 100ths plus 0. This thing started off with an identity. Started off with its name. Its name is negative 132.59, and we added something, and it didn't change its identity. So its identity didn't change. So this equals negative 132.59. And I keep using the word identity because this is the identity property of, is this multiplication or addition? Well, this is addition. All right. Next one, we've got two numbers. One of them is positive, one of them is negative. It's going to be kind of like what we did on number 1, except this will be, instead of multiplication, will be addition. So let's see, we have 201 and 75 100ths plus negative 201 and 75 100ths. Well, this is the same thing as saying this minus this. It's going to give us a total of 0. And the property we're going to use here with addition, or with multiplication, to find the inverse, you flip its fraction. You flip the fraction over. With addition and subtraction, the inverse is if it's opposite. It's like a negative. So on this, it's the inverse property of addition. All right. Number 4 is going to be kind of similar to number 2, except it'll be just multiplication. Notice our starting number has an identity. Its identity is 1/3. We multiply it by something, and its identity doesn't change. We multiply it by the number 1. Well, anything times 1 is whatever that anything was. So this is the, because its identity didn't change. Identity means it's like who you are. You might have a secret identity. This guy, it doesn't have a secret identity, and multiplying by 1 doesn't change his identity. So it's identity property of multiplication, because we multiplied and didn't change it. The next one, we've got 3.6 times 2.5 plus 3.6 times negative 2.5. So I'm going to start off, and I'm going to recognize that I have a 3.6 in both of these. Okay, so I want to rewrite this. And you wouldn't have to do it this way if you don't want. You could multiply these out and then add them together. But I'm gonna do the distributive property, where I'm gonna take out this 3.6, and I'm gonna recognize that this is gonna be 3.6 times two different things, times this plus this. Okay, so it's times 2.5 plus negative 2.5. So the property I use, and I'm just going to label it here up above it. This is the distributive property. I kind of did the distributive property backwards because distributive property means I'd multiply here and I'd multiply here. You might remember those two arrows from last year, but this was the distributive property we did. We just did it reverse. We did it backwards. And I recognize now that these two things make a total of 0. So now I have 3.6 times 0. Well, that's going to be 0. Okay. And that property, anything times 0 is 0. That is the 0 property of multiplication. For the next one, number 6, let's see. I know that I can do, I can reduce these 3's down to 1's. I can reduce these 2's down to 1's. And I'm just going to multiply straight across. But what property did we use? We used a little bit of the inverse property of multiplication. It's just kind of separated by this 4/3 here in the middle. But we've got 2/3 and we've got 3/2. So we're using the inverse property of multiplication. And we get the answer -4/3 because this now, if this equals 1, so I used the inverse property of multiplication, and I also used the identity property of multiplication. Because its identity didn't change. Once we use the inverse property of multiplication here on the 2/3 and the 3/2, this identity didn't change. It's the exact same thing. We got up here number 7. Almost deleted all this. Let's see what we can do here. I've got, how about this? How about we add those together? So this will be 3 times, 2/3. Let me double check. I think that might have been negative before. Okay, never mind. I wanna do the distributive property here instead. I want to do, I could do this parentheses first, and I could do this parentheses first, but I want to do the distributive property. I want to use these arrows, and I want to recognize when I have something outside of parentheses, I'd like to do this first. So we have 3 times 2/3. That's going to be 3/1 times 2/3 plus 3/1 times -1/3. So that's what these ones were. This 3 is this 3/1 and this 3/1. Okay, so it's 3 times this, 3 times this. Plus, I have 1/2 times -4/1 plus 1/2 times 2/1. And it looks like a lot of crazy math going on right now, but I'm going to get another color help us out. This 3 and this 3 turns into 1's and 1's. So this is 2. This 3 and this 3 turns into 1's and 1's. So this is -1. This 2 and this 4, we can reduce those by 2. So this will be -2. And this 2 and 2 can reduce to 1's. So that's 1. Now I see I have a 2 and a -2. That's 0. I have a -1 and a 1. Well, that's 0. So my total answer is 0. So we've got, what kind of properties did we use? We used the distributive. That was right here when we multiplied the 3 and the 1/2 by whatever was in those parentheses. We used the, let's see, here we use the inverse of multiplication. In a couple places we used that. We used the, what's the one where there's two opposites? I think that's going to be the inverse property of addition. We used this property where you have a 2 and a -2 makes 0, and a 1 and a -1 makes 0. So this is an inverse property of addition. We use those three problems, or those three properties in this problem here by himself. There's certainly other ways we could solve this problem. We could have added these fractions on the inside of parentheses, added these two as well. And we probably wouldn't have used this distributive, but we still would have ended up using these two properties if we did it that way. I'm going to go ahead and clear this page. So if you haven't got all these down, you might want to pause the video right now. But I'm going to clear it and then paste in my word problems that are on the next page. So for page 94D. All right. For this section, we need to write an expression involving negative rational numbers, to represent each situation. And then we need to evaluate or solve the expression and explain the value. The value means the answer. The value in the context of the problems. Number 8, experts say when you buy a new car, the value decreases 9%. 9% means 9 out of 100. In other words, 0.09, 9 in the hundredths place, when you drive a car off the lot. The Millers paid $28,456 for a new car. How does the value of the car change after they drive it off the lot? So what happens here is they bought this car, and experts have said that this value of the car, they paid this much, but right when they pull it out of the parking lot, its value is no longer $28,456. It's going to go down by 9%. So we need to multiply to figure this out. We need to figure out what 9% of 28,456 is. When I say of, that means multiply. And when I say 9%, that means 0.09. So let's go ahead and multiply this out. I'll do it over here. 28,456 times 0.09. 6 times 9 is 54. 5 times 9 is 45. Oh, notice I didn't line up the decimal. You don't have to do that with multiplication. 5 times 9 is 45, plus 5 makes 50. 4 times 9 is 36, plus 5 makes 41. 9 times 8 is 72, plus 4 makes 76. And 2 times 9 is 18, plus 7 is 25. So my next thing I have to do is count how many times this decimal goes over. So count how many times it goes over here. And my value is going to be decreasing, so I want to make sure this is negative. So my answer here, I've got negative $2,561.04. So the car's value decreased by $2,561.04. Notice I didn't write a negative here because I used a negative word. I used the negative word decreased. I could say it changed by negative $2,561.04. I could say it changed by a negative number, but I used decrease, which means this is negative. So I didn't include this negative that I wrote a minute ago. Number 9, a bottle contains 68 teaspoons of solution. The solution drops out of the bottle at a constant rate during 102 minutes of an experiment. The bottle is completely empty just as the experiment ends. At what rate does the number of teaspoons of solution in the bottle change? So we have a total of 68 teaspoons, which drips out at 102 minutes. I want to find out what that is for 1 minute. If I'm going to find the rate of change, if I'm going to find the rate, I want to find out per minute. In other words, per minute. So my final answer is in per minute. That's how you write rate. It's a unit rate. So let's see. From here to here, these are equivalent fractions. Notice I divided by 102. So I need to do 68 divided by 102. That sounds fun. So let's see. 68 divided by 102. I'm going to have to add a decimal, I can already tell. So put my decimal here. 102s and 680. Well, it's probably going to be 6. I know that's, so that's going to be a 6. 6 times 100 is 6. 6 times 2 is 12. Subtract. Make that a 10. 8, 7. So this will be 7, 6. 10 minus 2 is 8. And I'm going to bring down another 0. All right. And look at that. We get the same thing we had before. It's 0.6 repeated. So 102. Yep. So we're going to end up with 6 repeated. So at what rate does the number of teaspoons of solution in the bottle change? The number of teaspoons of solution decreases at 0.6 repeated teaspoons per minute, or 2/3. Okay, and we can probably see that if I reduce this fraction, I can divide by 2. 68 divided by 2 is 34. 102 divided by 2 is 51. I can divide these by 17. Kind of harder to see that, but I can divide by 17. And 34 divided by 17 is 2. 51 divided by 17 is 3. So 2/3 teaspoons per minute. Number 10, in golf, par on a hole is the number of strokes an experienced golfer should need to complete the hole. Par is represented by 0. Par is represented by 0. Scores under par are negative, and scores over par are positive. So notice this person did 12, 13, 14, 15, 16, 17, 18 total holes of golf. Okay. 2 times they got -2. 3 times they got -1. 12 times they got 0, which is 0 even par. And 1 time they went above par. So we need to solve this. We need to write an expression, which I guess we forgot that on a couple of these problems. But we did the expressions over here, so it's fine. So on this one, we need to do -2, and this happened 2 times, plus -1 happens 3 times, plus 12 happened 0 times, plus 1 happened 1 time. And we need to find out this person's final score. So let's see. -2 times 2 is -4, plus -1 times 3 is -3, plus 12 times 0 is 0, plus 1 times 1 is 1. So then I can combine those two negatives. -4 and -3 makes -7, plus 1 equals -6. And that's this person's score. No label, unless you want to call it -6 or 6 under par, if you wanted a label. But -6 is good enough. For number 11, Kame and 4 friends go to a water park. So we have a total of 5 people. Admission is $31.50 per person. So we're going to have a $31.50 for 5 people. Kame uses a coupon for $5 off of each ticket for up to 4 people. So we're also going to subtract $5 times 4 people, not for 5 people though, so we can't just take it out of that $31.50. Abby and Alan write expressions to represent the total amount Kame and his friends pay for admission. So we need to show that these two things are equal to each other. Rewrite the expression to show it is equal to Alan's expression. Let's see what we have here. This person, Abby, decided, well, for 4 of the tickets, I'm going to pay $31.50, but I'm also going to subtract $5 per ticket. So Abby says for 4 people, I'm paying $26.50. And then my 5th person is at $31.50. Okay, do we see those? You see how she described her situation. For Alan says, Well, I have 5 full cost tickets, and then I'm going to subtract my $20. So Alan did it a lot like I did. Alan and I are kind of thinking in the same way. But we need to prove that these are the exact same thing. So let's just go ahead and solve it. That sounds fine. We can rewrite it and show it, but let's just rewrite it and find the final answer for each one. So here we've got 31.5 times 5. 5 times 5 is 25. 5 times 1 is 5, 6, 7, and that'll be 15. Move our decimal over 1 time. So this is $157.50 minus 20 makes $137.50. So that's what Alan says he's going to have to pay. For Abby, let's do 26.5. I'm going to do it over here. 26.50 times 4. That's 0. That's 20. 6 times 4 is 24, 25, 26. 2 times 4 is 8, 9, 10. Move my decimal over 2 times. So that's at 106. Now we take our 106 and we add 31.50. 31.50. I've got 0, 5, 7, 3, 1. Decimal straight down. We see that these are 2 of the same things. Now technically I rewrote the expression with its final answer, so I have proven that these 2 things are equal to each other. So in order to justify each step, they wanted us to write properties of multiplication and addition, but our justification, I think we need to just say we solved both and got the same cost. And that's all I've got for this section. So don't worry, you're not going to be quizzed on these properties. You're not going to have to memorize all those. But I did want to spend some time on this lesson just to point those out and show you that they do exist and they can be helpful. And hopefully this section made sense. It's just a little bit of extra practice with division, multiplication, addition, and subtraction with rational numbers. So that's all I've got for this lesson. I don't believe I'll have a Google form assignment that lines up with this one. So you'll just have just the one for the division with rational numbers this week.